Lesson 4-6, the universal wave equation. When studying a wave traveling through a medium, it is important to note the following important ideas. One is that the frequency of the wave depends solely on the source. You cannot change the frequency of a wave by changing the medium. The speed of the wave depends solely on the medium. So if, for example, I wanted to change the speed of the wave as it travels through the air, the sound wave that I'm producing right now, the speed of the wave depends solely on the medium. So by speaking softly or by speaking loudly or by changing the frequency of my voice, I'm not going to change the speed of the wave. I may change the frequency because the frequency of the wave depends solely on me, but I cannot change the speed. I can't shout at you and make the wave travel to you faster. That may change other properties of the wave, but not the speed. And of course, the wavelength of the wave depends on the ratio of the speed and frequency. So wavelength is dependent on two things. One is it's dependent on the frequency, but it's also dependent on the speed. And so the wavelength, the higher the speed, the longer the wavelength, the higher the frequency, the shorter the wavelength. And this comes together in a small little equation where the wavelength, which we often call wavelength, we use the symbol lambda, all right, Lambda. It's a Greek symbol, it looks like this, and we say lambda is equal to the ratio of the speed divided by the frequency. So lambda is equal to v over f, and if we rearrange that and solve for v, we get something called equal to f lambda. And we generally refer to v is equal to f lambda as the universal wave equation. The universal wave equation, as the name implies, since it's universal, works for any wave, either mechanical waves or electromagnetic waves, whether they're transverse or longitudinal waves, it doesn't matter. The universal wave equation can be written in other forms. We start off with, of course, v is equal to f lambda. That's the one we derived on the previous page. Frequency times the wavelength. But we can also say, since the frequency is equal to 1 over t, all right, we discussed this earlier, we could also say that the speed of a wave is equal to the wavelength divided by the period. And now we cannot confuse these equations, the universal wave equation, for our equation v over t. All right, so we have, of course, v is equal to d over t. That works for any object, the speed equation using distance and time. Distance and time are not the same as wavelength and period, even though the unit for distance is the meter. The unit for time can usually be the second. Notice the unit for wavelength. Wavelength can be measured in meters, and time or period could be measured in seconds. So the units are the same. That's why we get v in both cases, but the concept is quite a bit different. So we have to make sure that the wave equation uses frequency, period, and or wavelength only. That's it. The speed equation uses distance and time. So we'll get some practice using the universal wave equation. It's fairly straightforward because it is quite a simple little equation. This is normally the form we'll find it in. And practice equations, just keep in mind that this equation works for distance and time. This equation works for frequency and wavelength. And they may seem similar, but they actually are quite independent of each other. All right.